Okay, so this was the question I have given in my previous video where I talked about click reaction in detail. So the question was, this is my starting material and I'm reacting it with sodium azide in presence of DMF as a solvent, and we are getting molecule A. Now this molecule A further reacts with this alkyne in presence of copper iodide at room temperature for 10 minutes and we are getting molecule B. So I wanted you to find out the structure of A and B. So let's go ahead and draw the mechanism for each step and find out the product. Okay, so let me write my starting material. So the starting material is a derivative of uracil. In first step, we are using sodium azide in presence of DMF as a solvent and we are getting molecule A. So this sodium azide will give me N3 minus, that is azide anion, and we have carbon containing chlorine. So this reaction is a type of substitution reaction, but we have two centers to attack. One is here and one is here. So what do you think? Which one is going to be replaced by this azide ion? So let me tell you that substitution is easy at sp3 carbon followed by sp2 and then sp carbon. This carbon right here is a sp3 carbon and this carbon right here is a sp2 carbon. If you know this, you will be able to draw the product, that this N3 minus will attack at this sp3 carbon and will displace this chloride ion. So the molecule structure of A will be so this one will be as it is. We have CH2 and we have replaced Cl with N3. So this is the structure of A. So let me redraw my A. In second step, we are reacting this with a alkyne. So we have a terminal alkyne in presence of copper iodide and we are getting molecule B. So this is what we call the azide-alkyne cycloaddition. We have this azide and we have this alkyne. So let's go ahead and draw the mechanism for this click reaction. So I can write this molecule as so this N3 part of azide is a linear part. So azide is a linear molecule, a neutral molecule, because we have a cation and an anion sitting on the same molecule. Now let's bring the alkyne group. So this is my alkyne. So let's draw the arrow pushing mechanism. This nitrogen with its lone pair will attack at this carbon, this bond will attack this nitrogen, and this bond will neutralize nitrogen. Let's number them 1, 2, 3, 4 and 5. So the product will be we have a triazole moiety So let's say this is my 1. So 1 is attached to 2, which has methyl group. 2 is attached to 3 with a double bond. 3 contains one hydrogen. 3 is bonded to nitrogen number 4 4 is singly bonded to nitrogen number 5 and nitrogen number 5 is doubly bonded to nitrogen number 1. So if I redraw this one, so I'm just redrawing this one here. Excuse me. Okay, we have CH2, we have nitrogen, so this is the product. I just redrawed it. Okay, so this is the product for this reaction. Okay, so here the alkyne part, which is a linear part, has approached the azide part in this particular fashion. Now alkyne is a linear molecule. It can do 180-degree flip and it can approach the azide ion in this particular orientation as well. So here we have methyl in the right side, but the alkyne can approach the azide molecule in such a way that the methyl can be in left side. So let's go ahead and draw the another possible product. Okay, so this is my azide. And this time alkyne is approaching like this. Okay, so mechanism is same. This nitrogen lone pairs will attack at this carbon, this bond will migrate at this nitrogen, and this bond will be used to neutralize nitrogen. So let's number 1, 2, 3, 4 and 5. So this will give me so this is nitrogen number 1 bonded to carbon number 2 which has hydrogen. 2 is doubly bonded to 3 which has methyl group. 3 is singly bonded to nitrogen number 4. Nitrogen number 4 singly bonded to nitrogen number 5, and this nitrogen number 5 is doubly bonded to nitrogen number 1. So this is the another product possible. So this is my one of the product. Let me name it as 1. And the second product we have drawn in previous slide is this one. So this is my second product. Now you are getting the mixture of product, but one of them is going to be the major one. So what do you think? Which one is going to be the major one? So I have already discussed this in my previous video, that you need to look out to the molecule related to the hindrance of the molecule. Okay, so you need to focus on the hindrance. So when this triazole moiety forms here, the methyl group is coming this side. But here the methyl group is coming this side. So this methyl is causing hindrance with this whole system. But look here, this whole group is sitting here and this methyl is far away, causing no hindrance to the system. So there is no hindrance to the system. But this molecule does give the hindrance, and that's why this one is the minor product and this one is the major product. Thank you for watching. Please do share and subscribe.